In this lecture, we look at three types of mapping techniques. There are limits of geometric modeling. Although graphics cards can render over tens of millions of triangles per second, this is still not a sufficient number for many phenomena, such as modeling clouds, grass, terrain, and skin. Consider the problem of modeling an orange, the fruit. We can model it as an orange colored sphere, but that will look unrealistic. Now here we have gone a little bit further than just simply putting orange color on a sphere. We do have some bumpiness modeled here. The orange still does not look very realistic. An alternate way is to replace this sphere with a more complex shape. Unfortunately, the rendering pipeline still does not capture some fine surface characteristics such as small dimples and orange. And moreover, increasing the number of polygons to capture the surface details would overwhelm the pipeline. Another alternative is to take a picture of a real orange and paste the image of the orange onto a sphere. This process is known as texture mapping. However, this still might not be sufficient because the resulting surface will be smooth and the reflections would still give the impression that it is a synthetic object. Hence, we need to change the local shape without going into rendering millions of polygons. We do this through bump mapping. There are three types of mapping techniques: texture mapping, environment mapping, and bump mapping. Texture mapping uses an image or a texture map to influence the color of a fragment. We paint the patterns onto smooth surfaces. Environment mapping uses a picture of the environment as the texture map. This allows us to simulate highly specular surfaces such as mirrors. Bump mapping adds small distortions to the surface normals before the mapping of the texture during the rendering process. This allows us to simulate small variations in shape, such as bumps on the real object, orange. Here we have an example of texture mapping. This is the geometric object. All surfaces are given white color, and after mapping a texture on it, it looks like this. See how the changes in the texture are more complicated compared to the shape. The shape is very smooth over here, whereas the texture varies significantly. This is an example of environment mapping. We have the same geometric shape. Here we have mapped the environment, a perfect reflection of what is present here in the environment onto the surface of the object. This is an example of bump mapping. We still have the same smooth object, but we have perturbed the normals so that it gives the appearance of a bumpy surface without having to go and define a large number of polygons here.